Hello, everyone, and welcome to the Houston Techfest 2020, the virtual edition. Before we get started, I want to make sure you're aware of a feature in the presentation that will make the session more interactive. Please make note of the question mark icon in the presentation screen. Click that icon and we'll open the question and answer feature, which will allow you to send the moderator questions to be delivered to our presenter at the appropriate time. So please feel free to post anytime during the session. We're excited to let you know that CodeMag is giving everyone a free subscription, so you can follow the link posted in the Q&A section. We are proud to present Garo. Sorry, I probably mispronounced that again. And he will be talking about the anatomy of a .NET Core serverless application in AWS. Go ahead and take it away.
All right, thanks, Robin. My name is Garo Azarian, and I'm a software whisperer and principal consultant at HeadSpring. And this is anatomy of a .NET Core serverless application on AWS. A little bit about me. I've been 17-ish years around, manager, leader, fun guy. I like to keep things fun and exciting. So as part of this talk too, if you have any questions, just go ahead and throw them on the chat, and I don't mind being interrupted, and we'll make it as interactive as possible. I'm a native Houstonian and went to school here, work here, and I'm also president of the Houston.NET Users Group. So you can reach me in my various forums online, and feel free to reach out. Twitter, I'm semi-active, not really, but I'm getting there. A website, which I'll eventually post something else on there, and GitHub, where a lot of the code, all the code from this presentation will be on GitHub, and I've got a few other things there as well. So a little bit about this presentation. So I've been working on AWS now more recently, and it was interesting to see all the pieces that come together to actually deploy an application into production. And I wanted to really talk through it, and I really like the .NET Core support in AWS, and I like some of the automation and deployment, and I wanted to really show what does an actual full application look like. So we want to talk a little bit about serverless, and we say serverless, but it doesn't mean serverless, because serverless really is made of servers, just like everything else that's in the cloud. It's all, on a server somewhere else. So it's important to kind of know that, yes, it's serverless, just means you have less control. It's serverless control of your server is really what it's about. And that makes it really easy for us to build on top of, because we just really care about that little layer in the top of it. If you're interested in how a serverless works, in AWS at least, it's actually based on this micro VM called Firecracker. And this is an open source VM infrastructure and plane. And so AWS takes this, it customizes it, and then it's really just container images on the top of it. So, Docker, and you'll know how Docker started, because it started from, it works on my machine, we'll ship your machine, and that's how Docker was born. So if you think about it, serverless is really just a small micro OS with your code running on top of it in a container. And that helps us kind of really frame how we run .NET Core in Lambda or JavaScript or Python or so on, because it really is just running code. So the code I run in my machine, if I run it in Docker, it will probably behave the same way as if I ran it in Lambda or in container in the cloud, or Azure Functions for that matter. It behaves pretty much the same way. Whenever I talk about AWS, I talk about serverless. I like to think of it in these kind of 4 categories. And this kind of helps me to break down the service, to understand how it works, how I should configure it, what it's going to cost me, and how do I connect it to other things. And every serverless piece that you work with, or even server full piece really, has these 4 components in it. So compute, which is the actual CPUs that are allocated. So if you look at services that are related to running a database, or services that are processing messages, or even just AWS Lambda, for example, to run functions, there's some aspect of compute, and there's some certain quantity of compute that's allocated for you. And that's your CPU and your memory. The higher amount that you allocate, the more it's going to cost you. And this typically is the heaviest cost in any sort of solution. So if you are pricing something and you know that you're going to need a lot of CPU cycles, then you know it's going to cost you more because it's related to the compute aspect of it. The other one is storage. Storage is, where do I put my data? And there's different ways to store information. There's different flavors, different databases. There's the bucket storage. There's all sorts of different ways to do it. The quality of storage is important because you pay them to store your data. And so how much storage you use is going to cost you a little bit. Storage is cheap though, so that's okay. The network is the input and output into your application, but also in and out of the cloud. So the network infrastructure in AWS costs you money to get things out of it and put things into, actually no, put things into it is not so much. So what they do is they get you on the way out because when you do upload something to the cloud, there's a really good chance you're going to pull it out as well. So they'll charge you on the way out. So if you think about something like, let's say Microsoft Teams, right? We're doing video and text and data all in and out of the cloud. And so when you have data that goes in, you're not being necessarily charged for it as much or at all. But when you're pulling it out on the flip side, so when you're looking at this presentation, then that's where they're going to charge different things like that. So that becomes really interesting. So that's why we make some choices in our architecture to reduce the cost of network transfer and to choose lower cost ways to do it. And finally, permissions, because the cloud is typically, when we say the cloud, is the public cloud. And so there are a lot of things that are not open on the internet. And so you have to make sure that the permissions are set up in a way that it prevents access to things that should not be accessed by people that should not access them. But on the flip side, allowing you to get into what you need to. The nice thing about AWS is that most of the resources have a default configuration that's fairly locked down, but it also means that for you to make services talk to each other, you need to configure how they talk to each other. And we'll explore that a little bit as we're going into the deployment. And again, anytime that you want to stop, ask questions, just pop it up and I'll have Robin interrupt me, and that's perfectly fine. I wanted to show a bit about the architecture. So this is the architecture of an application I'm going to talk about today. And what we've got here is we've got our users on the left, and they're happy users. And we've made a website called laughandgroan.com. And laughandgroan.com is going to be a place to share links to things on the internet that make you laugh or groan. And the idea here is that you'll share link content, it'll show up in a feed, and then other people can view that feed and see what it is that people have posted. And then eventually, it's not there yet, but it will be, to add ratings to it and say, okay, this made me laugh, this made me groan. And so you'll see kind of where your post sits in the meter of laugh versus groan. Well, we've got a few choices we made here. One is that I've decided to use Auth0 for the authentication. AWS does have an authentication system called Cognito, but I found that out of the box, it was not as nice as Auth0 was. And so this is why I decided to go with Auth0 as a tenant instead of using Cognito. The upside of this is that it gives me a login screen and Google integration pretty much out of the box. The downside is that the setup of it is not scripted with the automation that I put into the deployment. So you'd still have to set it up separately and then make the connection with the settings. A few key entry points here. So we've got two URLs that we're using. One is the main laughandgroan.com, which is where we're coming in on the web interface. So when you access the website, it goes in, and it's going to use a service called CloudFront. And CloudFront is a content delivery network, a CDN, that's used to host content from an S3 bucket, which is storage, and it's going to host it globally across the world. Or I've actually set this up just for the US, but you can choose how far the distribution goes geographically. The idea here is if you've ever heard of Cloudflare, what's happening is that your web traffic, your static content is cached on servers all around the world. And so the idea is that when you're accessing the website from the different cities, then the number of hops it needs to do to get to the content is shorter. And so you're able to get your web content faster. What's still going to take the same time, though, is the actual API call here to the API Gateway. But at least your front end is going to be served up quickly. We also use just the S3 bucket. S3 is, in Amazon, it's the simple storage service, but I think no one ever calls it that. Everyone calls it S3. And so S3 is probably the most pervasive service in AWS. And it's the one that really you're going to find a lot of use out of when you're not sure what else to use for some sort of integration or some sort of a automation or some sort of a strange thing you may want to do with AWS. Chances are S3 is somewhere in the middle of that you want to hook into. What we use it for here is really just to store our files. So we have a React single page application, and we're going to store the files in there for the web application. We also have a thing called Lambda at Edge. And what it does is add some secure headers, and I'll talk about that in a bit. Coming back to the API side, so we have another subdomain called api.laughandgrow.com, and this will go to the HTTP API Gateway. What the API Gateway does is it handles the HTTP traffic for you. And so the way it's configured in AWS, it will validate the authorization token that I get from Auth0, and it will filter and package the HTTP request and send it to my Lambda, which will execute it. And it will also do my cross-origin resource sharing CORS. It'll do my CORS related checks as well, so that I can put those boundaries on it.
We do have a question.
Sure.
It says, when approaching your architecture, do you set up your DevOps first before getting into your API and client?
So in this case, that's a really good question, because it's what comes first. And what I did here was I had an idea of how I wanted the architecture to look. So I started building my Lambdas first, because I wanted to go to what I didn't know first. And then I went in and set up some of the other stuff. In this example, once you hit a critical mass, the most important thing to do is to get something running and get something deploying so that you can cycle quickly. And so what I did was I used a technology called CDK, which is here on the right side, which made it really easy to start getting my environment set up. And I knew I wanted to use that, so I set that up first and then started setting up the scripts and setting up the automation so that I could deploy everything. So what I'd recommend is think about the minimum architecture you need to get something running. But when would you do it? I'm a consultant, so I'm going to say it depends. And everyone's going to groan at hearing me say that, but it's true. So because in this case, what I saw was I didn't know enough about DynamoDB starting this part. And so I wanted to make sure that I solved that problem first. I knew how to set up an API gateway. I knew how to set up some of the rest of the infrastructure. So I knew that would be easier, but I didn't know enough about Dynamo. And so I said, okay, well, first thing I need to do is test my understanding of Dynamo and build at least my core logic code that I could interface with Dynamo first and run those tests locally before I even deploy anything to the cloud. And I can run that thing first. Any project you're doing of any sort of complexity, it's important to think about the risky things you need to figure out and answer those questions first, get those problems solved. What you don't want to happen is have a bunch of infrastructure set up and then you leave the hardest problem for last and it's taking longer because now it's challenged your assumptions that you made earlier. So that's what I would be careful of going forward. Does that answer your question? If not, ask another. So we set up the Lambdas. And so the nice thing about setting up Lambdas with the API Gateway is that I don't have to actually handle the specific HTTP requests. I actually deal with messages that come from the Lambda runtime, and I'll show you what that looks like as well. Our DynamoDB tables that we're using and the indexes to actually store the data and run the queries. All of our logs go into CloudWatch, which is an AWS service for collecting logs, and it gives you some intelligence on how to monitor them. Then we've got a few other neat, simple things. So Route 53 is the DNS service in AWS. And this is super helpful because it lets you automate creation of your DNS records. And so if I wanted to create a subdomain, if I wanted to create a pointer to somewhere else, if I wanted to create more complex routing, I could use Route 53 to do this, and I could automate it through the stack. The other neat thing is that certificates issued by Amazon are free, I believe. What they do charge you for is if you want your own certificate authority, you get billed, but the certificates themselves are free, I think. I'm pretty sure. But what we do is we get a wildcard certificate. And so star.lackandgrow.com lets me create as many subdomains as I want on my main site and use SSL for that, using that same certificate. And then Amazon will automatically renew that certificate when it expires and keep it up to date for me. So I don't have to mess with it. Other important things, IAM, this is identity and access management. This is something that you're gonna look at and how the security is applied to your different services. I didn't have to do this a lot manually because of the deployment technology I used. And also the cost explorer to see how your resources are being billed, what are they costing you. It's important to keep that in mind. On the deployment side too, I use CDK, which is Cloud Development Kit. It is a TypeScript-based deployment technology that uses CloudFormation. And it has a lot of custom stuff that it does too. So it actually has some Lambdas that it creates, and it has a bucket or two it creates to store everything. But what I'm going to do next is actually walk through that little deployment code and show you some samples of what it looks like and what a deployment looks like. So you'll see an experience for it. The code for all this is on my GitHub, and I'll be adding some more information on the README of how you can do it yourself. But I want to just show the big picture through this presentation. So let's do some demolition. I'm doing that. All right, so let's do. So right now, let's start with what the actual website looks like. It's very extremely well designed, and so it has a login. And I actually just kind of pulled my login automatically because of Auth0. And it didn't do the. There it goes. There it goes. It's a little bit slow. So it pulled the little posts that I'd already created, and I can add another post. More, and then let's add a tech.com, post a link, and it will do its thing. I purposely kind of set this low on the resource scale, so it's still spinning everything up because it's the first time. And it will also, I need to add some more loading screens, things like that. So the way I've set up the Lambdas, it's going to do this cold start. So it's going to take a little bit of time the first call, but then the subsequent calls will be a lot faster once it warms up. Let's look at what, so there's a few ways I can go here. Let's look at what a Lambda looks like first, because I think that that's where I started. So I think it'd be interesting to see that first. So it's a surprisingly simple C# project. So let's look at the Lambda for creating a post. And we'll put here, post handler. And it is this guy right here. So the Lambda is really just a class. So we've got a class, post handler, and we've got a method, create, and this is my Lambda. And so it looks suspiciously like a regular C# method, which is what it is. It's a regular C# method. And what Lambda wants you to do is you have the first parameter is going to be a request, and it can be of any type. This is actually down in the weeds. This is the message that the API Gateway sends to the Lambda runtime to call your function. And so what we have here is the .NET implementation of that. And so this is what the actual message looks like. This is the payload proxy format. And it will do the serial, it will use their JSON serializer to convert it from JSON into the .NET object. And so I can work with all this cool stuff. So I can look at the version of the payload, the route key, I can look at the query string, I can look at any cookies that are sent with the request, I can look at all the headers. So what's nice is it's already parsed out the HTTP request for me, but it's also done some filtering, because I can say, well, I only want to see certain headers, and I don't care about any other weird ones that are coming through, so that if there's any sort of a weird injection attack or other sort of thing, it's not going to let it through. And it also will extract, request something, it'll extract parts of the path, and it will also give me my JWT token, pre-authorized. And so I configured it so that it would already give me, it would check my JWT token, my bearer token, for authentication, verify it against the issuer that I expect and the audience I expect. And so when the Lambda is called, I know that it's already an authenticated request.
Got another question sorry.
No problem.
So in the sample application, how do you deal with concurrency and data synchronization issues?
Okay. So one thing about concurrency is that the Lambda, this Lambda function will be called once per one at a time. So the Lambda function is created, it is executed, and then the next one is executed. What could happen is that if we have multiple concurrent calls, a new instance will be spun up in a separate Lambda instance, and then these two will be running concurrently on their own. So within the Lambda itself, within this code, I don't have to handle like locking or anything like that within the Lambda, because it will call one, I know it's going to call one at a time. Even in the async context, it's still going to call one at a time. But in the cloud sense, now concurrency becomes more challenging, because I know that I can be receiving multiple requests from different places. And I have to rely on the downstream data store to enforce certain things and to reject certain responses. So if I have a key in my data store, then I have to know that when I want to create a new item, that key should not match. But I also want to use ways that will allow me to create keys that won't collide, which is one of the really neat things I've got here. So one of the ways we do that with posts is by creating an ID using something called it's called a ULID. And I've actually got the page queued up somewhere. I had on another browser. So I have this thing, it's a thing called ULID. And what it is, it's a universally, lexicographically sortable identifier. And what's neat is that it's like a GUID, but it's sortable. So let me find the nice, here we go. This is the nice one. So what it has is it has a timestamp at the front, and it has a bunch of randomness at the back. And the randomness is from a cryptographically secure source. So we have our timestamp component, we have a random component, and that lets us create a global unique ID like a GUID or a UUID, but it's sortable. So if I insert these into the table and I sort them, now they're actually in chronological order. But it also means that I can request the IDs as much as possible, and as long as I'm using the same methodology to get the ID, they won't collide. And that's how I handle it in this case. Is it perfect? No, but it does a reasonable job of it. And I can at least enforce that we don't allow the IDs to be pushed from the client side. We only push it from sources that we control and understand. Good question, though, because I know when I first started to mess with the Lambdas, I know that I was like, okay, well, do I need to lock around this? Do I need to make sure concurrency is there? But I think that when you look at how C# uses HTTP clients, you end up getting HTTP clients are reused, but they're stateless. And so the infrastructure for HTTP client, the sockets that are collected and all that, like you're not meant to, you really don't create new ones all the time. You're expected to reuse the ones that you have and create a request message and send it. So it's pretty much the same basic idea. here, where the library calls can be done as much as possible because the calls themselves are stateless. And you'll have a request, you'll get a response. What's interesting to note is that in AWS, and this is something that is important to keep in mind, is that all the APIs in AWS are REST APIs. And I believe there was a AWS API reference, maybe. There we go. Reference index. This is probably way wrong. If you found where the actual list of APIs is, like the underlying API reference for AWS, it will eventually link down to the REST interface for it, and actually shows you this is the message I'm sending, and here's the response you're going to get back. Here is the status code. Here is what happens on an error. And so all this automation we're doing with AWS, it's really just a bunch of HTTP calls. It's HTTP all the way down for most of the calls around it. So when you're thinking of concurrency and you're thinking of coordination, just remember that it's all just web requests at the end of the day. And so as long as you frame it that way, then you know that, okay, it's going to be stateless requests. I know it needs to be authenticated. I know that I can make multiple requests from different places, and the order is going to be whatever it's going to be. And I hope that helps you, because I know that helped me really understand AWS a lot better, was to think of it in that way.
There was a follow-up on it. It just said, okay, use a CQRS pattern to handle data synchronization, ?
Yes, absolutely, for sure. CQRS, command query response separation, will really help you to frame your application in ways that will be more conducive to this, right? Because then you're looking at it as discrete actions that are happening as messages. And so if you want to go, let's say I'm doing this example with API Gateway, let's say I wanted to change it to a message queue-based approach. Well, it doesn't change how my code really works, because my messages still need to be sent in a certain order. I think I'd have some refactoring to do on this, because my creating a post is not idempotent. And so if I create the post twice, it's going to create 2 posts. And so I'd have to make some changes there to really follow it fully, right? To prevent some replay attacks and things like that. I could do that. There's ways in which you mess with it, but CQRS will definitely help you to understand your architecture and help you to scale out to a cloud level. Definitely.
Got a couple more coming in. One says, should concurrency be handled in multiple ways corresponding to business rules to avoid collision or overwriting data in the database, like the one you showed now?
Let's see. So business rules. So overwriting data is a business need. So like concurrency issues and uniqueness of data, these are all business type objectives, but they're also dependent on the underlying data store. And so what you may find is that your data store needs to be massaged to follow your business rules more closely. And Dynamo is one of those data stores where it has certain, like I had to massage it a bit to get it to behave, because there's things I expected from RDBMS that it did not do. And if you do have more complex rules, it may be better to go to a relational database, which lets you enforce those rules using ACID compliance. With the NoSQL database, it's a lot looser. It's eventually consistent. So what's going to happen is you need to prepare yourself for potential duplication and handling things after the fact. So if you do end up with a situation where something did get duplicated, then you actually need to have the check after the fact that looks for that duplication and resolves the conflict, or flags you and says, hey, something was duplicated or a rule was not followed, then you need to go back and fix it. So with concurrency in the cloud, you can either use a data store that will enforce that for you at the transaction level, or you're going to use a technique that's going to eventually be consistent, but it requires you to put more work on how you handle the exceptional cases. It depends on how you want to handle it and what your actual needs are. So depending on the situation, you may choose to go one way or the other. I think it really depends on your team's technical background and what you're most comfortable with, and you start in that direction. And say, okay, I can do this. Like I can do this side. I could have stored it in a relational database, and it would work just perfectly fine. And I could do it into a DynamoDB, and I could get it to work perfectly fine. But it does require a different way to address it.
All right, we got 2 more questions coming in. They're
okay.
Not necessarily related to concurrency anymore. Do you want to keep doing questions, or do you want to continue on?
Let's do questions. Let's do questions.
Okay. The next one is, how would you debug your code in a remote AWS environment?
You don't. What you do is you do console log. There's a few different ways to do it. Console log is the easiest, and it's going to end up here. So if I go to, I forgot which one of these is the one. So if I am trying to figure out what my Lambda is doing, there's really no way to attach to it to debug. And so what we have to do is we have to look at the logs and see what happened. So this is from, I believe, this morning, the 12th. And so I can look at start and report. So if I had, let's say, for example, I insert something unsavory into my website. Not that I would, but I could. Let's say I'm just putting in a blank. This one actually should be rejected straight out. So let's do, I'm putting in an FTP site. So this actually came, so this error actually comes through from the back end. So if I find this one, it should come up with some more logs. Come on, buddy, you can do it. There we go. So, for example, I can log exceptions. I can log. Let's zoom this in a little bit so you can see. So I can actually put full log entries in here and go and find them. And this is CloudWatch will give you some logs, but also there's a lot of cool searching things we can do. So I can set up other sort of searches and sorts. So the way I debug is I need to log things. And I'll need to filter those logs and find the entries that I'm looking for. So it's definitely not an easy way to go. There's not a way to directly attach to the running Lambda. What you can do though is you can run things locally. So what I've been doing is fire Visual Studio because it's easier to see in there. There's a test tool that we can use called the Lambda test tool. And when you install the Visual Studio AWS extensions, AWS Toolkit for Visual Studio, that's right. And let's get Visual Studio running. There he is. So I've got my Lambda code here, and I was actually testing one of them. So there's a target here called the mock Lambda test tool that gets added to a Lambda project. And I can run this tool. And what it'll do is it will actually create a close enough to Lambda runtime environment, sort of, but it's a test area. And it will fire up a web tool that will let you put in requests. So I can say, okay, this is the get me. So how do I structure the request? Well, this is where things get dicey because this is the actual AWS command that it's looking for this particular handler. So what I'll have to do is find where I had one of these. I had it in my clipboard. Come on, buddy. I see you. Yeah, there we go. So this was actually one that I did. This has an old authorization token, but this is what the content looks like. So what you'll do is you'll actually put in the text of what Lambda is going to send you. And I can execute the function, and it's not going to work because I have other things set up, but this will let me debug at least. So I can go into my running code, and I can go into the get me, and I can go into here and set a breakpoint. Cute. And so now I can actually step through my function here. It's set up to talk to AWS resources, so I can have the, if I have my profile set correctly, then I can actually send the commands to my running AWS. What I can also do is I can run my DynamoDB locally and connect to it locally. So when I want to run my unit tests, I'll actually run AWS Explorer. I'll run DynamoDB locally, and then I'll actually connect to it. Oh, this is problematic. What do you want? Okay, yeah, okay. I'll allow that this time. So I can run DynamoDB locally, and I can look at my tables, and I can examine my database like so. So there's a few options for debugging, but it's definitely not as direct as, because Lambda doesn't run like a normal service that runs all the time. Like if I had an Azure App Service, I could open up a port, I could connect to it potentially and debug. But in Lambda, the Lambda doesn't stay long enough for you to do that, because once you have downtime for a certain amount of time, it's going to get rid of it and make room for other resources. So here's some examples of posts I created. So you can actually mess with the local DB, but you can also connect to the host that's running in your cloud environment as well. So if I went to the one I'm running there, and I go to the one I have here, I can look at that data as well. And so this is my cloud data. So I can point to it just the same. Debugging is not as nice as it could be, but you have to find other ways to debug. Luckily, the tools like CloudWatch make it really easy to log things and see what's going on. And you can set alerts on these logs, and you can have other sort of looking through it as well. But the key is that Lambda code is really just C# code. It's not, there's nothing too terribly fancy about it. There's nothing too terribly unique about it. It's really just your C# code is running in the environment. Now, if we want to build it, I've set up a build script that will run everything for me. And I've used Pasake to do it, which is a PowerShell build script tool. And what I do is I will, oh, come on. No, I don't want to do that. Here we go. Let's do this one. So there is a .NET global tool called .NET Lambda. And this is what I use to build the .NET package for that. So it actually puts it into this publish folder laughinggrown.zip. And the zip file is what contains all my code. So if I want to look at that, I'll go into my deployment area. And let's take a peek at what it actually created when it did that. And it looks suspiciously not interesting, because it's really just a bunch of DLLs in a zip file. And because it's not complicated. So it's actually compiling all the code. And the only difference is that it will set up the depth file so that you can have the runtime it chooses. This is going to be small because Lambda supports .NET Core 3.1. Amazon has committed to support the LPS versions, which means .NET Core 2.1, 3.1 are going to be supported for the long-term support. However, in November, .NET 5 comes out, and .NET 5 will not be supported because it is not a long-term support version. .NET 6 is the long-term support version, which will come out later. So what you'll find is that if you want to use .NET 5 for Lambdas later, you're going to have to build a custom runtime. And remember how I said that Lambdas are just a VM running a container running your code. You can run it by just uploading a runtime along with it and have Lambda execute your runtime, which makes it pretty direct. It's really just, it's calling your code and it's executing it and it's spinning it up.
Thanks. So like a little bit of a response and et cetera. Sure. So okay. I did drop in the chat, maybe sometime at the end, there was a link to a debugger blog. They might want to take a look at and see if that kind of matches with what you're talking about or not. There were some follow-on questions about that, maybe sometime at the end for that. But then there's some other questions you want me to dive into those.
Okay.
So the first one is, what is the approach you took to test your code application, being different pieces of your application use different AWS services?
Right. So the only code I have is my C# code. And so I did write some unit tests about it. And so my unit tests will, let's do this. So my unit tests will actually use the local DynamoDB. And that's the one I was showing you in Visual Studio. So I can fire up the local one here. And then what I can do is then I'll just run my unit tests using Visual Studio. And let's do Test Explorer. That's definitely not what I wanted, but fine. So then I could just run my test locally, and it's actually going to create, it's going to rebuild the local schema in DynamoDB using the commands for DynamoDB over here, and then it will run my unit tests. So I can actually test everything locally with Dynamo, between a Dynamo and a Lambda running on its own. For some services you can do this, and some services you can't. But luckily there's a lot of, Amazon has a lot of cool, there's people that have created, because it's the best API, they've created a way to do it. There's a whole group of libraries called LocalStack, and this is great for setting up local AWS Cloud Stack for development and testing. And a lot of services are already supported here. So you've got CloudFormation, Dynamo, SQS, S3, it has all these things where it does just enough to make it work so that you can test your integrations locally without having to touch your cloud environment. And I'll pop this link into the presentation later too. So this way I can run my test. Hey, it passes, that's good. I'd be worried if it didn't. What broke? I wanted to talk a bit about deployment as we get into it, because I mentioned a bit about CDK, and then I'm going to do kind of a summary of the presentation stuff afterwards, or the deployment stuff. So I use a thing called CDK, and CDK is Cloud Development Kit, and it's a way to express deployment in terms of TypeScript. And so, for example, my Lambdas will be this bit of code right here. So this is create the post. And so what I'll do is I'll say, okay, it's going to be a Lambda function. It's going to be, this is my internal name for it. I want you to use the .NET Core 3.1 runtime. I want you to pull the zip file from my relative path here. This is my handler. And the handler is really just a way to tell the Lambda runtime which class it needs to call. So it's going to be assembly name here, your DLL, your fully qualified namespace and class, and then the name of the method. And it's just going to, depending on the runtime, like .NET Core 3.1, it'll parse this differently. So if you have JavaScript, it's a little different notation. Python is slightly different notation. Excuse me, Java is also different. I want to hold logs for 30 days. And then I want the function to time out after 30 seconds, which means that one function call should not take more than 30 seconds to execute. And if it does, burn it to the ground. Because if something went wrong and I don't care. We'll repeat that as we go. The gateway is very similar, where we set up the different parts of it. So we set up an HTTP gateway, we set up our DNS records, and we set up the actual routes. And so what we're doing is we're building all the different parts of this architecture in TypeScript, and then this turns into a deployment. So when I'm ready to make a change, then I will set up some environment variables, and I'll set this one, then I'll do my build script deploy publish. And so I set up a build script for automation that will basically build all the DLL changes, build the C#, build the JavaScript, and then also build the deployment scripts, and then send everything to AWS, as well as my front end. So my front end is really just a React single page application, which is standard issue React SPA here. So I put it all in the same repository just to make it easy to get to. And so it'll just build and execute. There's a few things that we would need to think about still that I haven't quite done yet, which is making the site configurable. And so there's still some Webpack nonsense I got to do to make this work. But it's not too terrible. Let this run. So you can see it's building the Lambda. It's going to be building the code. It's going to zip everything up, and it's going to start the actual deployment process to send it to AWS. What's really nice is that the command line tool will actually do the deployment. So it'll send all of my DLLs and zips and everything into AWS, and then it will actually use CloudFormation to run the deployment. It's worth looking into CDK. This is something that Amazon has been pushing pretty recently. And what I found was that it's definitely, there's a few different ways to do deployment automation. This was pretty straightforward. It has its quirks, just like everything, but the support in VS Code is really nice to do IntelliSense. The documentation is reasonably okay. If you go to the CDK documentation, it's nice. It's not terrible. If I go to, let's say, Lambda real quick, and I look at overview, so it talks a bit about which packages. It supports other languages, but not as well as it supports TypeScript. And it gives you some code examples of how to use it. And the super nice thing is that it does permissions for you. And that's where this is really super helpful, because setting up permissions manually is a huge pain in the butt to set up the role and add the right permissions to it in AWS. But when I do it here, I can just set up this integration here, for example, for the API Gateway. I don't have to pick the permissions myself. It will assign them for me and make the changes, which is super helpful. And like I said, all the code is hosted on my GitHub. So I think if you want to explore it more, I suggest going into it and taking a look. I'll put the links in the presentation at the end, and ask me any questions you've got. So this is going to do the deployment, and it's going to do its thing.
You want to take a second for a couple questions?
Sure.
Cool. The first one is Lambda is a quote-unquote Docker image running in a container. So every request requires a container to run. So why not place the HTTP request on AWS SQS?
Yeah. And that's actually one strategy to use too, is to use SQS to serialize the requests. So if you were directly posting it, but you'd have to directly post it into SQS. So if I'm trying to access from the web browser, and we can switch back to presentation because we can talk about that. So if I'm going from a web browser, I have a few options. SQS does have an HTTP trigger that I could use, and I could put the message onto queue and then handle it that way as well. And then I could even have it where SQS will choose the Lambda based on the type of message, and there's different queues, but Lambda does it for you. And so there's no point if you're just looking for the sequential request and you want to do it in Lambda, then what I would do, because I'm saying if you want to do only one at a time, let's say, for example, where it's like, okay, only one can execute in my entire cloud, let's say delete. Delete can only be run one at a time, let's say, for example. So what I'll do is there's a setting here called concurrency. And so I can edit concurrency, and I'll say 1. Or actually, let's just reserve. That's not what I want. I want somewhere else there's a max concurrency. Where are you? Provisions, asynchronous invocation. Somewhere in here, there's a way to set it where only a maximum is 1. And the idea there is that you'll only execute one call ever at a time for your Lambda. Or you can say, I want to go concurrent and say as wide as you want to go to my old account. So you could do SQS. For certain messages, it makes sense. Lambda will do something similar on its own already, because it will queue the requests and process them in the order they're received, and it will fan out the instances as it needs to process it. So CloudFormation, I want to talk a bit about kind of going through a little bit of the lessons learned. So because we're down to 10 minutes-ish. And so I wanted to at least kind of summarize the points that we got, and then we can take any other questions as we go too. And you can always reach out to me afterwards as well. So with C# Lambda, the NuGet packages are great. Like there's a lot of individual packages that are small, so you can pull in just what you need. And Lambda entry point, it's just a method. The class will get called when the Lambda instance is started. And so when I was seeing my post handler here, I was doing it in VS Code because it's easier to read. So when I look at my handler for posts, then what I'll see is that this initialization code gets executed once. So I'll initialize my post service, and this is actually going to full configuration. It's going to set up a few things, but that happens once, and then it'll call my function as many times as it needs to in that particular Lambda, which means that initialization can be handled once, which is a cold start, and then there's a warm start afterwards in each individual call. So as an API call is more active, then it's going to stay warm for longer, and it's going to be faster to execute. But if you don't use it so much, then you're going to take a hit the first time it comes up, and it may take a second or two for it to pop up the first time. But the C# aspect of it, and that's generally Lambda, but C# aspect of it is spectacular. It was really easy to get going, really easy to debug and go. Authentication with Auth0, I didn't go into this too much, but there is a tool called Cognito in AWS. I don't like it, personally. I liked Auth0 in, it was super easy to get started, and it gave me what I wanted out of the box from a login screen. And it gave me the Google authentication as part of it as well, and just kind of talks you through the steps. So I thought that was spectacular and really easy to use. I spelled accounts with 3 C's. I just noticed that. Great marketing stuff. Free tier is really good. 7,000 users, 2 social logins, and get someone else to do your authentication because it's not fun at all. CDK, TypeScript was great. It has because I've done CloudFormation with YAML. I've done Terraform. Terraform is very powerful, but the IDE support is not great in terms of the IntelliSense and code completion. Using it on CloudFormation is super helpful. So if any demo you see on CDK, it's really just set up your profile and then CDK Bootstrap, and it will set it all up, which is great. More on this later though. Static website hosting, I found actually off-the-shelf pattern, and if you go through the CDK code that I've got, the deployment code, I use the off-the-shelf component here, and it will set up the S3 bucket, the CloudFront, and the security headers, which is something that everyone does with hosting static websites. And so it's really easy to just pick that piece off the shelf. The ULID, I kind of got into this earlier. If you're looking for a way to generate unique IDs, this is a very, very, very good way to go, other than GUIDs. This is becoming my default go-to for generating unique identifiers because it's faster than GUID and it's more sortable in the database. Because every time we make a GUID, chances are we're throwing it into a database somewhere. So this is a great way to go. And there's a NuGet library called NULID, and it's got a lot of cool features. It's really nice, really simple. I highly support it. Hard parts. CDK. I ran into a lot of weird problems. So when you're working with CDK, pin the versions. I think a lot of the guys will tell you this, but I cannot stress how important it is that anytime you bring any of the CDK libraries in, you need to pin the versions. Otherwise, you'll have a hard time. There's a lot of experimental tag stuff, and it will change. And they explicitly say they don't follow semantic versioning, and so you'll see some breakage. The multilingual support is there, but it's not as good as Python and TypeScript support, just in case you're going through it. For the API Gateway, I put this note here because Amazon has a bit schizophrenia on that, on which one you want to use. I tried V2. I like V2 better so far, but it still doesn't have as many features. I put this note here on cores because if you want your cores to work, this is the little bit over here. Allow these headers and then put that list in there. If you don't do this, your cores will not work. And I learned this at about 4 o'clock this morning, and it all worked. But I found deep into the internet that if you make these headers the headers that are allowed in the configuration, then it will work. If you don't do these, then it won't work. There it is. Operationally, the logs are not terribly great. Like you saw CloudWatch. CloudWatch is okay. The API Gateway logs themselves, they're not as detailed. So that can be hard to go through with some of these AWS services. Dynamo, go through the documentation. This try and try again. It's just test it, test it, test it. This is why I did this code first, because I didn't know enough about Dynamo and I knew that it was weird. and I needed to make sure that I understood how it's going to behave before I actually implemented it. So that's a really good one to keep in mind. And that's lessons learned. So any other general questions, or if there's anything you'd like me to go more deeper into?
There are 2 remaining questions.
Okay, hit me.
All right, so to run C# code, you need .NET CLR. So is Lambda running in a Dockerized container on AWS Linux image?
For my local one, no. For my local one, it's actually just hosting a Lambda-like environment. And all it's doing is it has, it sets up one thing to look at here. So when I run my Lambda, it has this Lambda context. And so what it's doing is it's actually just newing up the class, and it's creating a test context. So it's running it all in Windows, or whatever, whatever your OS is, it's running it there when it runs the test tool. So it's minimal impact, minimal surprise when it comes down to it. There are ways to run Lambda in a Docker image if you want to run it on Linux. And there are some, like local stack that I was showing you earlier was one way to do that, so that you can have a Lambda. Here it is, AWS Lambda. So what you can do is you can run a Lambda-like runtime and actually communicate with it locally to test out interactions with Lambda. But most of the time, all you're looking for is, I need someone to construct a message correctly, and I need to understand how to respond correctly. And that's pretty much what you need to debug.
Thank you. All right, so this is going to be the last question. What
Okay.
is the trigger for Lambda functions from HTTP request? Can you show it?
So from HTTP request, basically it's this API Gateway trigger. And what it's doing is, from this trigger, API Gateway will allow it to come through. And so I can set up the route this way. So it's really like post ID. For this one is the delete post function. So the trigger is that API Gateway request. And so when I ran the test tool, I had it in my clipboard. I could show it real quick. Quick. So this is the request that's coming through. And what it's doing is, it's just a JSON payload. So the useful bits are here, request context. This is actually extracting the JWT token and what I had in the authorization. So you can see, like, it has my API and my scopes that I want. It has my issuer, and it has my user identifier. And then the stay path. Where are you, buddy? I know you're here. Route key. There was a path. Oh, this one. Oh no, this is because this is forget users me. So there's the paths are actually going to be passed into this for the ones that have the path, and then so there's a way to there's a list of the different path values that are in the route as well. So it will pull that together. I generated this just by logging it. So when I came to the get me, I just added a log line here for me, and I just serialized the object so that I can have it, have a copy of it for funsies. All right.
So there are some more questions coming in, but is there some personal contact information you can give the group so that they can ask more additional questions offline?
Sure. So this is my contact slide. If you look for Gary Yuri, I'll be in all the usual places. The source code is in my GitHub repository under Laugh and Groan. I'll post a presentation there too, and I think there was some other links and things I wanted to add to it. But yeah, hit me up on LinkedIn, Twitter, GitHub, whatever.
Okay. Thank you very much, and thank you all for attending today's session, and thank you for sharing. The recording of the session will be available at HoustonTechFest.com soon. I hope you enjoy the rest of your virtual Houston Tech Fest, and have a great day, guys.
Thanks. Have a great day, everybody. Thank you, Robin.
Yep.